Alright, and one last video. I'm going to go ahead and talk quickly about inverses because those are also going to be on this test. And I'm not going to actually solve anything. I'm just going to remind you guys how to do them. So here's just a few blank spots for notes. So inverses. Speaking of the tables, so if I had some values in this table, let's go ahead and do just the quadratic parent function. So let's orient it around 0. So -2, -1, 0, 1, and 2. So at 0, I know I'm at 0, 1, 1, 2, 4, 4, something like that. So for a table, if you're given a table and you're asked to find the inverse, or if you're given individual points and you're asked to find the inverse, then what you're doing is you're just switching the x and the y value. So generally speaking, for inverses, I'm just going to say switch x and y value. Switch your domain and your range. And that's pretty well what you're doing on every single thing concerning an inverse. So speaking with a table, you're switching the x and the y value of the coordinate. So switch x and y value of the coordinate. So if I'm going to find my inverse, remember that little -1 right there? That's the only thing that signifies inverse. So 4, 1, 0, 1, 4, -2, -1, 0, 1, 2. That would be the inverse of this function right here. Graphically speaking, again, easy concept. Let's just go ahead and stay with the parabola. I'm going to graph these points. It's going to look something like this. This is all estimation, guys. But there's the parent function of a parabola. And then if I found its inverse, it would look something like that, which is actually a complete reflection over that line. Sorry, I actually made a mistake right here. It would look like this right here. So let's graph it on the same one. So it should be a perfect reflection over the y equals x line, just to make that clear and very quick. So reflects over y equals x, or the linear function. I will be right with both you guys. Just a second. This is going to take a few more seconds. So to find an inverse algebraically, again, just like I wrote up here with inverses, switch the x and the y. Again, all you're doing is switch x and y and solve for y. I'm sure your English teachers aren't going to be super happy with me using n twice like that, but that's okay. Find the inverse, switch the x and the y. So I'm going to just rewrite this real quick with x's and y's. Remember, h of x is almost a different way of saying y. It's just saying h is a function of x. So y equals x squared. We're switching the x and the y. So I'm going to have x equals y squared. Then simply take the square root. I got to solve for that y. So I'm going to take the square root of both sides. When I do that, it's plus or minus equals y. Once I've solved for y, that is the inverse. So there's the inverse algebraically. Let me do it one more time, or I'll just do it with the last two real quick. Switch the x and the y. So I've first y equals 1/3 x plus 2. Switch the x and the y. So I'm going to subtract 2 from each side. X minus 2 equals 1/3 y. And then I'm going to multiply by 3 to get rid of that 1/3. So I've got 3x minus 6 equals y. And that is the inverse. One last time. Oh, look at that. Somebody was trying to show you something. Okay. So 3x minus 6. So if that was the inverse, I'm just trying to show you what I see right now. I should end up, by finding the opposite of this, getting back to here. Notice that these two things are the same. So if I find the inverse of this, I'm going to get back to that point. So let's see if that's true. I'm going to, instead of writing out the x and the y, I'm going to switch them before I do that. 3y minus 6, just like that. I'm going to add 6 to both sides. So I've got x plus 6 equals 3y. Then I'm going to divide by 3. So 1/3 x plus 2 equals y inverse. Notice that part right there is the same as that part, just like I assumed. All right, so that is all I'm going to do on inverses, and if you guys have more questions, come see me in tutoring, and I'll talk to y'all later.